Guys, this is chapter 2 of Mechan 2310. Okay, remember in chapter 1 we have talked about some basic terminologies and concepts, and it serves for introduction to thermodynamics. Okay, but those would not be the main content of thermodynamics, because we are just establishing some vocabularies so that we can communicate more easily. And in this chapter, we will really go into learn the knowledge in thermodynamics. Okay, as I've said that in the very beginning of chapter 1, thermodynamics is the study of energy. So of course we need to know what energy is. And this chapter, besides talking about what energy is, we will also talk about different kinds of energy transfer, as well have some general energy analysis using the first law of thermodynamics. Okay, so here is the content of this chapter. Okay, so we will have 4 sections here. So the first section we will talk about energy, so what energy really is, and different forms of energy. And in 2.2 we will talk about energy transfer, different modes of energy transfer, etc. And 2.3 we will talk about is efficiency, because in thermodynamics one of the main topics that we will discuss is how to design an efficient device. Okay, so we need to know how to measure the efficiency. And we will conclude this chapter by talking about some of the environmental issues related to energy. Okay? So as you can see, I have put down a figure here. So what is this figure for? Okay? Well, as we know that the conservation of energy principle is familiar to all of us. However, if we would like to apply it to thermodynamics, we need to know more about it. Okay? The below example may show our insufficiency in understanding the conservation of energy principle. Okay, as shown in this figure. Okay, this figure is actually consists of a fan inside a well-sealed and a well-insulated room. So let me ask you, how does the air temperature change? Okay, so pause this video and think about it. Okay, for 5 minutes. Okay. Okay, so I assume that you have thought about this problem over a very long time. So let us see what's the real answer. Okay, what's the actual answer? Well, someone may think that if you sit near the fan, there should be some wind blowing from the fan and you will feel cold. You may think that the air temperature may get lower. Okay, it's totally wrong. Okay, because if you examine the system carefully, you can see that there is some electrical energy drawn by the fan into the room. Okay, and as we can see that this room is well sealed as well as well insulated, energy is released to the room and it will make the air temperature increase, because this is an adiabatic closed system. That means there will be neither mass transfer nor heat transfer. Okay, this example shows that we need to have a better understanding on energy so that we can know more about the energy transformation involved in a certain system. Okay, we will first discuss different forms of energy, and then we will go to section 2.2 to talk about different mechanisms of energy transfer. So let us go to section 2.1. So this is section 2.1. Okay, energy, and we will talk about different forms of energy here. Well, we usually classify energy into 2 forms, macroscopic and microscopic. Okay, macroscopic means very big, and microscopic means very small. Okay, so macroscopic forms of energy refer to those a system possesses as a whole. Okay, as a whole, all of the things inside the system. Okay, with respect to some reference frame, for example, kinetic and the potential energy. Okay. So of course, the kinetic energy here should be the kinetic energy of the whole system, instead of the kinetic energy of the molecules inside the system. Okay, and other kinds of macroscopic energy may include electrical energy as well as magnetic energy. Okay, for the microscopic one, they are related to molecular behavior. Okay, like bond energy, kinetic energy inside the molecules, etc. Well, they have no correlation to any reference frame. It's not like the kinetic energy we describe in a macroscopic way. Okay, it will depend on the reference frame. So we will discuss this one in the next subsection. If we add all of the microscopic forms of energy together, we will have a term to collect all of them. That will be the internal energy. We will use capital letter U to denote internal energy.